Alright guys, by the end of the day today you'll be able to decide if one rectangle is a dilation of another rectangle and how to use a center and a scale factor to describe dilation. You also will be able to use comfortably these key terms: dilation, scale factor, circular grid, and then you'll also be able to apply dilations to figures on a circular grid when the center of dilation is the center of the grid. And on this activity, you need a piece of 8.5 by 11 and some scissors. We're going to go ahead and cut the dimensions in half, as it says here, and see, based on the resulting side lengths, which group we'll put them in. We'll have two different groups. So if we look at our original rectangle A, we know it's 8.5 by 11. Now rectangle B has one of the dimensions, the height, cut in half, so that's why the height is half of 11 or 5.5, but the width is still 8.5. Notice that C has both the height as half of A and the width as half of A, so that's something unique for A and C. We would say that C is a dilation of A. D has a shared width of C, but the height is half of C, so that's not a dilation of A or C because only one dimension was cut in half. The last one, rectangle E, we see that E has half a height of C and half a width of C, so we say that E is a dilation of C. So A, C, and E go together. Okay, so A, C, and E, and then B and D. Okay, what I want you to do now is take those rectangles and line them up together. So A, C, and E together, B and D together. Now when you stack them on top of each other, you'll notice that when you pass a diagonal through rectangle A, it goes through the diagonal of E and C. That means that the width and the height were proportionately cut. In other words, that's our definition of scale factor. When you multiply each dimension of a shape, so in this case the width and the height, if you had a triangle it would be all three sides, and same for B and D here, a diagonal, they have a shared diagonal. Okay. Now when you stack them all on top of each other, we noticed that A, C, and E, the red ones, have that shared diagonal, and it differs from the shared diagonal of B and D. Let's take a look now at our concentric circles, our circle grid. We'll be working with these a little bit. Now I want to look a little bit more in detail here. At center P, out to circle C is 2 units, okay? And then from P to D is 1, 2, 3, 4, 5, 6. 6 to 2, in other words, 3 to 1, so it's a scale factor of 3. The radius of circle C is 1/3 that of circle D. In other words, D has a radius 3 times longer than circle C. We also can do scale factors. In this case, let's look at a scale factor of 2 of a quadrilateral on a circle grid. And we're looking from P to C, so let's count them. 1, 2, 3, 4, 5. So if we're doing a scale factor of 2, C prime would be out 5 more spaces, 6, 7, 8, 9, 10. Okay, so there's our scale factor of 2 to C prime. To D prime, from P to D, it's 1, 2, 3, and then 3 more to D prime, 4, 5, 6. From A to P is 1, 2, 3, 4. So 4 more, 5, 6, 7, 8. So that's the A prime. And then P to B is 2. So 2 more to B prime. Okay? And that's how we do this. So what we can do at this point now is connect each of these points and get a rough image here of what the resulting quadrilateral would look like. So here is A prime B prime, and then our last side length here, A prime D prime. And so there is the dilation of ABCD, A prime, B prime, C prime, D prime. So this is the type of skills that you want to be comfortable in. Lastly, we'll go and take a closer look at this. We have QF is 1, 2, 3 units. QF prime is 1, so here we have a scale factor of 1/3. Our dilation in this case is smaller than the original shape. So QG is 6 units, so that means QG prime would be 2 units. QH is 1, 2, 3, 4, 5, 6, 7, 8, 9. So how long would QH prime be? Well, divide 9 by what? 3, or multiply by 1/3. That's right, okay? You go ahead and finish up QE prime. Sketch your dilation of EFGH as E prime, F prime, G prime, H prime. What I want you to do now is just have a look and understand that yes, there may be triangles on a circular grid. Any type of polygon can be sketched on a circular grid. Now it's the end of the lesson. You should have a good understanding of what a dilation is. I want you to write it in your own words into the discussion on Canvas. What is a dilation? Okay? And then make sure you can do the practice problems from lesson 1 and lesson 2. This is the cool down for lesson 2. There's also some practice problems linked on Canvas, so make sure you do those and ask any questions in office hours. Okay, until next time, signing off.